Okay, good afternoon. So I guess we're gonna get started now. So today what we're gonna do is we're gonna talk about functions and combining functions graphically. Now before we get into something like this, because we wanna do something graphically so we have a visual, and then later on we're gonna do algebraically and then graph whatever the combined functions. Now, before we dive on to something like this, I want to show you something from the textbook and from the workbook that you have. So if I could just ask you to turn to 4.1. And it says there, combined functions. So we already know our basic functions in here. We know how to graph, we know what they look like. But even with functions or a graph of the functions, we can do operations with them. We can add, we can multiply, divide, subtract functions. So it says here, our focus is doing this graphically so we have a visual. So here's an example. If you look at the bottom here, construct understanding. So the graph below shows two functions, two different functions. And function A is a college enrollment, and function B is a university enrollment for the past few years. So in function A, this is a college, this is a university. The question is, on the same grid, sketch a graph to show the total post-secondary enrollment for these years. Now, what does it mean by that? What's the total? How would you figure out the total enrollment? What would you do? Take the points, and what do you do with the points? Add them together, right? Right, add them together. So we know that here in 2004, okay, I'm going to ask you this. In 2004, what is the enrollment in millions, I guess, for a college? 6 million. Okay. What's the enrollment for university? About 10 point. This is 10, maybe 10.1 or 10.2, right? Okay. So what is the total enrollment? 16. So where would that be? 16.1 would be up here, right? Or 16.2. It's a little bit difficult to figure that out exactly. Okay, good. So what did we do? We took 6 and we took 10.1. Add them together to get 16.1. What about in 2005? What is the What is enrollment for college? 6 as well. Okay. And university? About 10.5. So if there's 6 million and then the other one is 10.5 million, how many? So 16.5. So 16.5. What about in 2006? About 16 point. Oh, you're adding them together already, right? About 16.8. At least slightly above, right? And what about this one? In 2007? About 16.2 or 16.3, and then the other one would be okay, so this is going to be 6 point, say about 6.2, and then the other one was about 10.9 or 10.8 maybe. Yeah, so this one would be 17. Did I do 17? No, it's okay. And lastly, 2008. 6 and 11.1 maybe. So it's going to be 17.1. This is going to be 6, and then this is going to be 11.1, so 17.1. Okay, so how did we do? How did we do that? We added them together. What did we add? Did we add the x or did we add the y? We added the y, right? This is interesting. So we can connect them. Yes, yeah. Now we'll actually gonna show that over here. I'm gonna try to.
Pardon for interruption. I get the owner of the gray Honda H2C 780 license plate number, as well as a white van license plate number KBF 157. Please move your vehicles as they will be towed if they are not moved in 10 minutes. Thank you.
So I'm going to break it down. So this is basically what's happening in here. We have the x, right? And then we have the f of x, which is the y value for that function, because we have two different functions. And then we have the g of x. And then over here, the last one is f of x plus g of x. Now we didn't have to add the x, right? We want the total enrollment. Total enrollment. The enrollment is the y value. So if here in 2004 we said it's going to be 6, and then this one here is about 10.2. So if you add them together, it's going to be 16.2. Is this too late, or can everybody see it? Yeah. In 2005, it's going to be f of x, the function a, is 6. G of x is 10.5. So that's where we got 16.5. Okay, so we're actually putting it together so that we're in a table form so that we can combine them. 2006, it's still about 6.1 maybe. Oops. 6.1, and then this one would be about 10.8, so it's going to be 16.9. Is everyone good? 2007, 6.2, this is slightly higher, and then this one here is going to be, I think, 10.8. So that's going to give us 17. Okay, so this is what the points are. The year is not changing. The year is not changing, but we want the sum of the y values for each of the function. Okay, and then we were able to graph it. Let's take a look at this one. There's a scenario in here. Let's read the scenario first, and then let's see. We got two functions in there. The stopping distance for a car is a function of speed of the car when the brakes are applied. Okay, stopping distance for a car is a function of speed of the car when the brakes are applied. So stopping distance, that gives us the reaction time distance, and then the braking distance. So imagine, like you're driving, and then by the time you react, you're still moving. Your car is still moving, right? So there's still a distance being covered while you are reacting to, let's say, a boy crossing the street or a cat or whatever. And then when you brake, you don't stop right then and there, right? There's still a distance while you are braking. Your car is still kind of moving along, and you could probably relate this if you're driving. Right? So there are two functions there. By the time you reacted, right? There's a momentarily thing there, and then when you're braking, you're not completely stopping. You're slowly. You're still covering distance. So you got the speed here, and then your distance. So it says here, the graph below shows functions for stopping distance and reaction time distance against speed. On the same graph, sketch the graph for braking distance against the speed. Braking distance. Describe your strategy. So braking distance, if you want the braking distance, and then so this is what we're looking for, and then your stopping distance, and then the reaction time. So if this is what we're looking for, you got your stopping distance here, and then this is your reaction time. What's the difference between, on same grid, sketch the braking distance against the speed? So what are we trying to do in here? Are we gonna add them? So this is what you have. This is your first function. And then you have your reaction time. How can we figure out the braking distance? Subtract, right. So what we're gonna do, stopping distance minus reaction time equals to braking distance. I'm just gonna switch pens in here. Okay, so we're gonna subtract. Okay, so sometimes it's good to have this as a table of values, right? So instead of just the x, we're not gonna do the x anymore. We're gonna call this f of x, and this is g of x. So f of x is our stopping distance, and then the g of x is our reaction. And then this one will be our braking distance. We'll call it b of x. Just for, okay? So here, let's do it point by point. The first one, we can go x here, speed. So that we can organize it, I guess. Let's say the speed is 0. If the speed is 0, what is the stopping distance? 0, okay? So the stopping distance is the curve. And what is the reaction time? The reaction time is this, the line. It's also 0. And the b of x will be f of x minus g of x. Okay, 0 minus 0 is 0. What if somebody is driving 20 kilometers per hour? What's the f of x? The f is the curve. 10, yeah. And what's the g of x? So the g of x is the line. Okay, this is 20 kilometers per hour right here. And then we're looking for the g of 20. That's 5. Okay, is everybody okay? 5. So the stopping distance minus the reaction time, so that means that the braking distance is 5.
Where did you get the 5?
Where did I get the 5? It's from this point. So if the x is 20, the y goes up by 5. Went up 5. You see that? Okay, so good. So let's go to, well, I guess 30. We can go to 30. So at 30 kilometers per hour, what is the stopping distance? It would be up here, right? So this is 30, and then that's 15. If x is 30, y is 15. What about the other one? The line.
6 or 7?
You know, kind of approximating. Let's say maybe about 7. Okay, so 15 minus 7 give us 8. 40. 40 would be, it's going to be 20 for f of x. G of x is
9.
would be about 8 or 9. No, 8. That's going to give us 12. Let's do 50. What's happening? If x is 50, what is the y for f of x? About 27. And what is the g of x? G of 50? 10? 17. So from here, what are we going to plot? What are we going to plot? We're going to plot the speed against the braking distance. So 0, 0, 0, 25, so 25 would be here, 38, 30, and then 8, 40, 12, 40, 12, 50, 17, okay, so we can see the growth in here. We can continue on until we're finished everything. Okay. So we said we can add functions, we can subtract functions, we can multiply functions. Now I think what we're going to do is we're going to go and just do this one here. We're going to see something similar here. This is probably better. Now we have two functions. One is f of x, one is g of x. So it says here, the graphs of f of x and g of x are shown in the same grid. Sketch the graph of the sum of these two functions. Okay. So what we could do is we can create our table of values and plot the graph. Okay. Okay. There we go. I like how they have some points already in here to kind of guide us along. So we're going to use some of those points. We're going to pick the points on for x is 0, x is 3, x is 6, and then x is 9. Is that okay? So we got, for our x values, we got 0, 3, 6, and 9. Now let's just focus on the f of x. F of x. If x is 0, what is f of 0? 2. Is everybody okay with that? Yes? So if x is 0, y is 2. Good. If x is 3, 3. If x is 3, y is 3, or f of x is 3. Okay, what about 6? Okay, if x is 6, f of 6 is 4, right? It's this one here. 4. If x is 9, what is f of 9? 5. Okay, good. Now let's take a look at the g of x. Okay, if f of x is, sorry, if g of x is 0, what would that be? 6? Oh, okay, thank you. 3. F of, remember, it's this one that we want, right? The g of x?
We're looking at g of x, right?
Yeah, we're looking at the g of x here. We're looking at this g of x.
What's that, 3?
Okay, when x is 0, look at this one. Maybe it's better this way, if I do it this way. This is 0, 6, yes? So x is 0, g of 0 is 6. What's this point?
3, 4.
3, 4. When x is 3, this is 4. What's this one? 6, comma 2. So 6 is x, 2 for y, and last one is 9, 0. So it's 9, x is 0. Okay, go ahead and add both f of x and g of x and start plotting the points. See where the points go.